All right, we are recording right now, guys. Okay, so yesterday I shared this sheet with you. We're gonna go over the answers here. As you can see on the first page, he says, I claim that 80% of the people in my district will support my tax increase. Since it is a percent, you can see, guys, how HO is stated, P equals 80%. The alternative hypothesis, according to what we did, it's not equal to, so P is not equal to 80%. Let me go through, you try it, the ones that did not have answers. So try writing the null hypothesis and the alternative hypothesis for each of these scenarios. A company has a medicine that's being manufactured, and the company claims on average each pill contains 14 milligrams of active ingredients. Okay, what did you guys put here? On average. Contains means equal. So that's equal 14 milligrams. That's their claim. And what would be the complement to equal, guys, as you learned yesterday? Can someone tell me, please?
Different.
Not equal, different. I cannot emphasize enough how important to know step one, guys, because if you put the wrong claim to begin with, you will be processing the wrong claim. So that's very important to master this part. And that's why I spent quite a bit of time doing this. Okay, let's go to the next page. There you go, number 2. The school principal wants to test if it is true that the juniors use the computers for schoolwork less than 70% of the time. So it's a percent. You put P and P to begin with. Since he says less than 70%, you cannot put the less than 70% in here because the less than should be in the alternative. So it turns out to be in the alternative. This is the claim. And can you guys tell me what would be the null hypothesis?
Greater than?
Or?
Equal
Or
to.
equal.
Or equal, yes. Remember, guys, these two come together. Always, always, always. No exceptions. An economist claims that the average price of a home in a certain area is 800,000. Is an equal sign, guys. And then you know for sure that this is not equal here. And the claim happened to be in HO. In the book, he gives you a lot of problems. Some of them have the claim in HA, but there are some who have the claim in HO. A researcher says that more than half of all Americans are overweight. What's the variable, guys? Can you choose one of those?
E less than 50.
B. It says more than half. So it's going to be P more than what? Half or 50% if you like. It's either or, it's okay. That's the claim. And then P will be less than or equal to. Remember, guys, you cannot put a less than in HO. It has to be, HO, guys, has to be one of those. Always, always, always. And HA has to be one of those. And I'm going to put the ones that compete with each other. These two compete with each other, and these two compete with each other. So always, guys, decide, is it going to be these two, or these two, or the last two? No other choices. You make other choices, then you make wrong hypotheses. At a manufacturing plant, a certain product is supposed to weigh at least 12 pounds. So this is the mean. Okay, what is at least, guys?
Less than or equal.
If you say at least.
More than and equal.
More than or equal. Yes. More than or equal 12 pounds. This is the claim. And guys, see, if this is more than or equal, then this is less than 12. Okay, before I move on, let me just put those signs and make sure that you guys, if you see this, that means at most. And this one means at least. It is less than or equal to, this is a greater than or equal to. And for sure, guys, you know that this is more than. There are many times where students know exactly what they're doing, but they mix up the signs and then they end up, just doing the wrong work. And this is a less than. So this is less than or equal to, guys, and this is greater than or equal to. In the book, he says probably at most or at least. So it's good to know those signs. Let me see.
The first one on that page.
What is it?
The first one on that page.
What was the first one?
Yeah, number one. Number two.
Yeah, here you go. Contains 14 milligrams. They say is 14 milligrams. So equal and not equal.
Okay.
Okay. Okay, let's see. Anything else? No. All right. Let's move on to the material now. Okay, just 1 second. I think we finish up to page 4. So we did this. We defined the p-value. We saw the video about the importance of the p-value. We did type 1 and type 2 error. We discussed them. And okay, we're here. Some more definitions before we get to the heart of it, guys, and we do a problem. This is something I did yesterday with other groups, so we had the chance to do few more minutes. If your hypotheses are written like that, mu is less than or equal to 100 and mu is greater than 100. So if HA has a greater sign, a greater than 100 means you have to go to the right. When you go more than 100, on the number line, it will be to the right. So this is called the right tail test, guys. So a right tail test when you have this sign. This is a right tail test. Now, a right tail test, your p-value will be an area to the right. Now, what is a left tail test? Watch, this is a left tail test. When the alternative hypotheses have a less than sign. Less than 100, if I want to go less than 100, I'm going toward the left because I'm going, on the number line to the left. So this is called the left tail test. So there will be homework questions where he gives you these two and asks you, choose the type, the nature of the test. Is it a right tail test, left tail test, or two tail test? If it is greater than, you choose right. If it is a less than, you choose left. Now, what is a two tail test? Two tail test when you have something like this. Equal or not equal. The 100, I just made it up, guys. I just put anything to give you examples. When I say your score on the test, I claim that your score on the test is different from 80. But does that mean it's more than 80? No. Does that mean it's less than 80? Probably less, probably more. This is why they call it a two-tailed test, guys. So a two-tailed test will be a different from. And the p-value will be split up on both sides. There's half of the p-value on the right and half of the p-value on the left. Okay, so these are definitions of the nature of the tests. We have right tail test, left tail test, and two tail test. Okay, let's do this example. And for each claim, state HO and HA, then determine whether the test is left-tailed, right-tailed, or two-tailed test. So assume, guys, you don't see the answers. A school publicized that the proportion of the students who are involved in at least one curricular extracurricular activity is 61%. So is, guys, means equal 61%. HA will be P not equal to 61%. And as you know, the not equal sign means that we have a two-tailed test. Number 2. A car dealership announced that the mean time for an oil change is less than 15 minutes. You see, guys, the less than, it's right here. And then a greater than or equal will be the null hypothesis. And remember, the less than means a left tail test. Your p-value is going to be an area shaded to the left. Even the calculator is going to shade it to the left as well. Number 3. A company advertises that the mean life of its furnaces is more than 18 years. Look at the more, guys, than 18 years. And once you see this, you know that this is a right tail test. These are just terminology, get used to them. And your p-value will be an area shaded to the right. Now, how do we make decisions based on the p-value? You guys, you're gonna have to try to, not to try, to memorize this from now till the end and use what you memorized just now to answer all the questions on the next test and the final exam. We will be using, as I described yesterday, there will be a level of significance alpha. This is the maximum allowable probability for making a type 1 error that will be given to you in the problem. And then the calculator will help you find the p-value. And this is how you compare. Alpha is a percent and the p-value is also percent. So we're comparing apples with apples, oranges with oranges. If the p-value is less than alpha, you reject the null hypothesis. And if the p-value is more than alpha, you fail to reject the null hypothesis. This is it, guys. This is going to be the foundation for us to make decisions when we do hypothesis testing based on the p-value. If the p-value is less than alpha, we reject the null hypothesis. If the p-value is more than alpha, we say we fail to reject the null hypothesis. I tell students, try to memorize it this way. P-value low, HO must go. This is another way if you can memorize it this way. So p-value low means less than alpha. When it is less than alpha means it's a small p-value. HO must go means we reject it. We reject the null hypothesis. So this is how we're gonna make decisions using the p-value approach. And you will see that, guys, in a minute or two when I do an exercise, okay? So please remember this. If you like, guys, just write it down on a piece of paper right now, so because I'm gonna need it every time I do a problem. And then you will see how we're gonna make decisions based on this fact right here. I will come to this later. After I do one single problem, I'll come back to this. But now I'm just gonna do an example on how to use the p-value. Example. You perform a hypothesis test for the following claim. How should you interpret your decision if you reject HO or if you, no, let's leave this, that relates to that, I'll leave it. And I'm gonna go to a problem now. All right. These are the steps, the 5 steps I've been talking about, guys. So this we'll revisit later after we do step 5 in a problem. We state the null and the alternative hypothesis, guys. That's step number 1. We calculate what we call the standardized test statistic. I've been mentioning Z here. There will be a Z or a T. So changing the values that are given to you from the sample to a z-score. Calculate the p-value. You will not have to calculate this one by hand. We will use technology. Make a decision to either reject HO or fail to reject HO. That means if the p-value is less than alpha, we reject HO. If the p-value is more than alpha, we fail to reject HO. And then interpret your decision in words in the context of the claim. At the very end, guys, when you make your decision, you have to make it available to a reader, someone who doesn't understand statistics. So you're going to tell them at the very end, do you support the claim or you don't support the claim? Do you have enough evidence to support the claim or you don't have enough evidence to support the claim? This is going to be done in words. This is step number 5. And once I talk a little bit more about this, I'll go back, just to those exercises. What I would like you guys to do now, I'm just going to pause for a minute. I would like you to grab your calculator and see. I just want to make sure that you know how to use the calculator properly. If you can perform those 3 values for me using your calculator. Remember, the numerator, you have to put it between parentheses, denominator between parentheses in order, to honor the order of operations given to you in this exercise. So let's take a minute, guys, and try to find those 3 values, and I will demonstrate them after 1 minute. Okay, the first one, I put 110 minus 105 between parentheses, and then I divided by 12 over square root of 35 between parentheses, and I got 2.47. That is correct. For the second one, same work, guys. You just do 10.1 minus 11.4. So let me just do it. You should get, your answer is correct for this one. 10.1 minus 11.4, close, then divide. And 5 over square root of 12. Open parentheses, 5 divided by square root of 12, and close. Here you go. Yep, negative 0.90. Since it is a t, it's usually 3 decimal places, as you know from chapter 6. And the last one, let's see what the last one is. I got 0.55 minus 0.52. So between parentheses. Divide by, and I think there is a square root. Open parentheses. And what we have, 0.55 times 0.45 divided by 200, and now close and exit. There you go. 0.85.
I don't want to be confusing, but there's a feature on your calculator where you can just put the fraction bar.
Yeah, you could do that. Yeah, you could do that. However, you guys probably won't need, just to do those calculations, but I want you to appreciate, those programs that we're going to access later a lot more than you do appreciate them, because you will see how this is going to be done on the calculator without any efforts from your side, guys, to do so. All right. Now, guys, help me out. You have the p-value and you have alpha. Compare the p-value and alpha and tell me what you do here. You reject HO or you fail to reject HO. So we're going to practice step number 4. The p-value is 0.0237 and alpha is 0.05. And you guys agree with me that 0.0237 is less than 0.05. For students who get a little bit confused here, this is how I compare, guys. I take the whole digit with the whole digit. 0 is 0, so they are the same. Then I take the 10th digit, they are the same. Then I take the 100th digit here, it's 2. The 100th digit, it's 5. Well, 2 is less than 5, then the whole thing is less. What you do, guys, you should reject or fail to reject the null hypothesis. Can someone tell me, please? What's the decision here? Reject. Because if the p-value is less than alpha, we reject the null hypothesis. Exactly. Okay, let's say if alpha is 0.01. So the maximum allowable probability of making type 1 error is 0.01. You know, guys, 0.0237 is not less than 0.01. It's bigger. So should what? I should what? What's the language? Exact language. Fail to reject. Don't change fail to reject to accept, guys. I fail to reject, it doesn't mean that you accept. If I fail to reject an argument with you guys and I tell you I give up, it doesn't mean that I accept it. I just fail to reject your argument. I don't have enough evidence to reject it. It doesn't mean that I am in acceptance. So do not try to change the word fail to reject. Actually, when you do your homework online, it's gonna give you reject or fail to reject. It's not gonna give you the word accept instead. You should fail to reject the null hypothesis. All right. All right. Now, how do we find the p-value before we run those tests? I'm just going to show you an example here. So there is this example. And then we'll come to a complete problem in an example right after. Find the p-value for the left tail hypothesis test with the test statistic equals z of z equals negative 2.23. Okay, let me sketch it, guys, and show you what the p-value. He said it's a left tail test, so the p-value is gonna be right here. I told you the p-value is an area to the left of the test statistic. He gave me the test statistic here to be negative 2.23. Do you guys still remember from chapter 5, how do you find the area to the left of z equals negative 2.23? We need the area to the left. It is a normal CDF function. And can you guys help me put the 4 arguments here? What are they? What is the left bound here?
Minimum is negative a million.
Negative a million, negative 1,000 is good. Then negative 2.23, then a 0, then a 1. What you guys said, area 0, 1, it's the inverse norm, is to find z, but we have z and we need a probability. Probability is always normal CDF. This is the p-value, guys. Let's see what it is here. It's gonna be small, you will see. So second, distribute, normal CDF, enter, and I got negative a million or 1,000, it doesn't matter. Negative 2.23, comma, 0, comma, 1, close. It's 0.0129. Okay, he says compare it with alpha equals 0.01. What do you say, guys? Is it bigger than alpha or smaller than alpha? Do you guys agree with me that this is bigger than alpha?
Yeah.
And the decision will be what? Fail to reject HO. Okay, find the p-value for a two-tailed hypothesis test with a test statistic of z equal 2.14. Okay, let me show you this, guys. You won't need to do any of this later once we introduce because the tests. This is a two tails, guys, so there are going to be 2 p-values. And this is the 0 right in the middle. And this is the 2.14. It's enough, guys, to find the area on one side and multiply it by 2. So what would be this area right here? Normal CDF. Okay, lower bound will be 2.14. Upper bound is the sky is the limit, 0, 1. There you go. Let me see. Normal CDF. 2.14, comma, 1,000. Just trying to show you guys that the p-value is nothing but a probability. It's an area. 0, comma, 1. Okay, I got 0.0162. So my p-value is twice as much because it's a two-tailed test. So my p-value is, only for two tails, it's twice as much. So 0.0162. And if we multiply this answer by 2, guys, I get 0.0324. And what did he say alpha here? He says alpha is 5%. So what do you think, guys? Is this more than alpha or less than alpha? Yes?
Less than?
Less than alpha. You reject HO. When you reject HO, guys, you're saying that you have enough evidence against HO. So HO is not good. That means HA must be good. This is how we're going to be making decisions. All right. How do you change a value if you have X bar, if you have the standard deviation, if you have the sample size? How do you change that to a z-score? We talked about it yesterday. The formula that you learned in chapter 2 was this for z-score. But since we are using the samples, we said if we change this to X bar, this one is going to become over square root of n according to chapter 5. So that will be the test statistic, and that will be the formula that the calculator will be using to find your test statistic. And I'll just put the z right here in the center. All right. Ready, guys? We're gonna do the first problem with all the 5 steps, and you're gonna see how to perform a hypothesis test and make decisions. So please pay attention, and then I would like you to help me with the next one. In auto racing, a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. So what they're saying, guys, they're claiming that they can change 4 tires and refuel the car in less than 13 seconds. Can you guys, first of all, I'm gonna pause for 30 seconds and I have you write the null and the alternative hypothesis. So the first statement usually would allow you to write the null and the alternative hypothesis. Why don't you do that? Okay. They say it's less than 13 seconds, so I hope that you guys put 13 seconds in here. This is the claim. And that will be greater than or equal to 13 seconds. Step number 1 is done. Now he's gonna give you information from a sample that they collected. A random sample of 32 pit stop times. So N is 32, guys. Has a sample mean of 12.9 seconds. X bar is 12.9. Very close to 13, little bit less than 13. Assume that the population standard deviation is 0.19 seconds. So guys, here, he's not giving you S, he says, I'm giving you sigma. So sigma is 0.19 seconds. Right away, once you see the word sigma, you know that you're performing a Z distribution test, not a T distribution test. Is there enough evidence to support the claim at alpha equals 0.01? All right. You're ready to see how the calculator is going to perform step 2 and 3, and then you will be able to do step 4 and 5. So let's get ready. Turn the calculator on. I'm going to clear the screen and watch, guys. You go to stat, you go to tests, you go to Z test. So section 7.2 is Z test. Okay, what's your input? Did he give you an entire data set or he gave you a summary? He gave me a summary, so it's stats. Okay. Mu0, what goes in there? It's the value that you're doing the hypotheses against. It's the value 13, so you put this value in there. Now the calculator is asking you to input the value of sigma, which is 0.19. Then X bar. If you like, guys, as I do this work, if you want to take a screenshot of the calculator for each question, and then when you go later, you just try to do them on your own, and then you have the screenshot of the calculator, just in case if you're not playing the entire video and something goes wrong, then you can refer to the screenshots. X bar is 12.9. N 32. Okay, now let me tell you what this one is before I go to hit calculate or draw. The last step, guys, is to select the alternative hypothesis sign. Not where the claim is, it's what is the sign in the alternative hypothesis. So what is it gonna be, guys? The first, second, or third? First, second, or third? Let's see, the third. The third says greater than.
Second.
It's the second one. I don't know how you see the calculator. Probably you've seen it mirrored. I'm not sure, but it is the second. The first one is not equal to, guys. The second one is less than, and the third one is greater than. And what you see there is less than. So it's going to be the second one. And hit calculate and watch. Z is negative 2.98. So all you need, guys, from the calculator is this one and that one, the p-value. So negative 2.98, I'll write it down. And the p-value, guys, is, here it is one more time, 4 decimal places, 0.0015. It's very small. All right. Can you make a decision, guys, now? The alpha is 0.01. Put it next to it and put the sign. Is the p-value less than alpha or more than alpha, guys?
Less than alpha.
Less than alpha. So what's the decision in step number 4? Do we reject HO or fail to reject HO?
Reject.
Reject HO. All right, I'm ready now to give you the last step, which is the conclusion about all the work you did. So let me repeat. I'm going to be redundant here, guys. I'm going to repeat stuff. We stated the null and the alternative hypotheses. Then we used the calculator to find the test statistic. Then the calculator also helped us find the p-value. Then the p-value, we found out that it was less than alpha. Alpha is given, guys. It will always be given to you. It's right here. Because the p-value was less than alpha, we reject HO. Now step 5 is write a conclusion in the context of the claim. Okay, here's how we do it. My claim, listen carefully, guys. My claim is in the alternative, as you can see. And I rejected the null hypothesis. If you reject the null hypothesis, guys, that means you're saying the null hypothesis is no good. Then you are saying that the alternative hypothesis is good. Then you end up supporting the alternative. So if your claim is in the alternative hypothesis and you reject the null hypothesis, you support the claim. And here's how we write it down. We say there is enough evidence. At what significance level? Just like in the interval, we say with 99% confidence. Here, we have to state the significance level. There is enough evidence at the 0.01 level of significance to support the claim that the mean, I'm just going to copy it and paste it, mean pit stop time is less than 13 seconds, and that conclude the problem. Is this good news for the pit crew guys or not good news? What do you think? Does this market them well, you know, with this exercise, or we're saying that they're not efficient? Any ideas, guys? We're saying we're supporting the claim of the pit crew. That means we are saying that what they're claiming is correct. So that means they're reliable, and that's gonna market them big time because we are supporting their claim that they can change 4 tires and refuel a car, a race car, in less than 13 seconds. Any questions about this exercise? So this will give you the first flavor in how to perform a hypothesis test. Now, if I had to do this by hand, guys, I should have used this formula. And I'm going to show you, if I put, you know, the information, I should get the exact same number here. This could have done like that. Watch. Z equals X bar, guys, is 12.9. That's the formula I'm using. Minus the mean. You pick up the value from the null hypothesis. Divided by sigma, which is 0.19 over square root of 32. Well, I'm not going to do the math, guys, but if you do it, you're going to get negative 2.98. That's what the calculator gave you. Now, the p-value, guys, it turned out to be 0.0015. Since I have a less than in the alternative hypothesis, this is a left tail test. So if you want to see, have a visual of the p-value, this is your p-value, guys. The z that you found, which is negative 2.98, your p-value would have been the area to the left. This is the p-value. And you could have used normal CDF to find it. If you use normal CDF to find the p-value, you will put negative 1,000,000, normal CDF, negative 2.98, comma 0, comma 1, you should get this one. So p-value is attached to the step number 2. I cannot do step number 3 without finding step 2, and this is how the calculator works. The calculator finds the test statistic Z, they call it a test statistic, and then based on that, it will use it to calculate the p-value. Any questions, guys? We're gonna do another exercise. So if you reject HO, and your claim is an HA, you support the claim and you write this language. There is enough evidence at the 0.01 level of significance to support the claim that the mean pit stop time is less than 13 seconds. Why you have to include the level of significance? You have to tell the reader there is a 1% chance that you could have rejected the HO when it was true. So made a mistake, made a type 1 error. You have to include this. All right, let's go to another exercise. Okay, I'd like you to have your calculator handy, guys, and work with me on this exercise. According to a study, the mean cost of weight loss surgery is $21,500. You think this information is incorrect. Okay, you randomly selected 25 surgery patients and find that the average cost for their surgeries is $20,695. The population standard deviation is known to be 2,250, and the population is normally distributed. Is there enough evidence to support your claim at alpha equals 0.05? Use the p-value. If using technology, it is z-test. Okay, guys, can you first of all tell me what's the null and the alternative hypothesis are? I appreciate your participation, guys. So this is another example. Number 1. So this is a continuation. Again, I'm just still doing section 7.2, and then I'll go to 7.3 right after this. The EPA reports that the exhaust emission for a certain car model has a normal distribution with the mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. So sigma, guys, is 0.4. The car manufacturer claims their new process reduces the mean level of exhaust emitted for this car model. A simple random sample of 31 cars, so N is 31, is taken and the mean level of exhaust emitted for this sample is 1.21. State the null and the alternative hypotheses. Can you guys tell me what the null and the alternative hypotheses here are? The car manufacturer claims their new process reduces the mean level of exhaust. And we know that the mean level of exhaust is known to be 1.45. Can someone tell me what do you think the null and the alternative are going to be? Any suggestions?
Is it mu is equal to 1 point?
He says reduces. If reduces, if I say I want to reduce, you know, this number, that means I'm claiming that my number is what?
Less?
Less, exactly. That's good. So just get used to it, guys. It's not going to be like x plus x equals to x in this chapter. It's going to give you the problem and he expect you to read between the words and the lines to figure out, you know, what the claim is. So this is the claim. And now we know, guys, the null hypothesis has to be the total opposite, which is 1.45. Okay, I'm ready to use the z-test. You see, once you figure out, you know, what the null and the alternative, just go to your calculator and start using the z-test here. Oops, stat, test, z-test. Okay, mu 0, 1.45. Then sigma, he says it's 0.4. X bar is 1.21. And N is 31, guys. And we're testing that the mean is less than. The alternative hypothesis is less than. I'm gonna hit calculate. Okay. Z is negative 3.34. And the p-value, watch, guys, again, before I remove the calculator. It says 4.179 e minus 4. I'll write it down and just interpret it. Okay, here's what it means. It means you have to move the decimal point 4 digits to the left. So it will be 0.000417955. If you want to do 4 decimal places, guys, it will be 0.004, which is definitely less than alpha. It's very small. I don't care what alpha is. Here he says 0.01. So we reject HO. What's the decision? We reject HO. What do you conclude about the mean level of exhaust emitted for this car model? Okay, we reject HO and our claim is in HA, then we support the claim. So we say there is enough evidence at the 1% level of significance or 0.01. You can put 0.01 level of significance to support the claim. To support the car manufacturer claim. All right. So this is how we do hypothesis testing when sigma is known. Now for number 2, guys, pay attention to this one. You're gonna see it's exactly the same thing, but he doesn't give you sigma, he gives you the sample information, sample standard deviation. The amount of water consumed per week by Montana residents is normally distributed with an unknown mean. A simple random sample of 26 residents, so N is 26, has a mean value of 120.3 gallons. So X bar is 120.3 gallons. And a standard deviation of 10. He didn't say it's a population standard deviation, so he just call it S. The city of Bozeman claims that the average water consumed in the state of Montana is not 125 gallons. So it's clear, guys. He's telling you what the claim is. Mean is not 125. So then your null hypothesis will be equal 125. And you guys understand why I put not equal in HA, because HA only can take not equal, less than, or greater than. So it has to be right here. Since S is given instead of sigma, as we did in chapter 6, guys, we don't do a Z test. We did a T interval in chapter 6. Here, instead of T interval, we do a T test. So your test statistic is going to be pretty much the same as we did before in the previous section, but instead of sigma, guys, I'll put S over square root of N. And it's not called Z anymore, it is called T. However, guys, you don't need to calculate this by hand. Your calculator is going to do the work for you. So watch. You're going to go to stat, tests, T test, stats. Okay, mu 0. What is the value in the null hypothesis? 125. Let me see if any question. Oh, we knew it is T because he gave me sample standard deviation. He didn't say population standard deviation. Once there is no mention to population standard deviation given in the problem, it is a T test. X bar, what was X bar, guys? It's 120.3. What was S? S is 10 gallons. And N is 26. And now we're testing that mean is not equal. The alternative is the mean not equal mu 0. All right, calculate. There you go. You see, it says T. T equals negative 2.39. We need the 3 decimal places, so it will be negative 2.397. And look at the p-value, guys. I'm just gonna copy and paste them. And my p-value is going to be 0.0224, and then the next one 35, so it will be 4. All right, what is alpha here? I think it's next. It's coming next on the next page. What is the decision at the 0.01 significance level? Well, p-value, guys, is 0.0244, which is, I think you agree with me, it's bigger than alpha because alpha is 0.01. So do we all agree that it's going to be fail to reject HO? And I forgot here to put where the claim is. They say is not 125 gallons. So this is where the claim, guys, is. Okay. We could not reject HO and your claim happened to be in HA. That means you cannot support the claim. There is not enough evidence. At the 1%, as a 0.01 level of significance to support the claim. that the consumption of water is different from 125 gallons. So we're saying we cannot support this claim. That concludes this question, guys, using the t-test now. The next one, it's again a t-test, and you will see why. I'm going to tell you again how to distinguish between the two. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage. So their goal is to increase the card usage, which has a current mean of 2,500. Okay, can someone tell me what would state for the null and the alternative hypothesis? They want to increase the card usage. What would be the null and what would be the alternative? The current usage is $2,500 per year, and they want to increase it. So how would you state that? Any suggestions, guys? If I claim that the frequent flyers will increase card usage, that means I want the spending to be what? Bigger, more, exactly. So we need the spending to be more than 2,500. This is the claim using frequent flyers. So your null hypothesis, guys, will be less than or equal to 2,500. All right. What did they do? They gave free miles to a simple random sample of 24 credit holders and found that the sample mean to be X bar is 2542. So there is an increase, but is it significant? With the sample standard deviation, you see the word sample standard deviation, guys? You cannot put sigma here, it's S of 109. Okay. Find the test statistic, find the p-value. We're not doing the critical value yet. Make a decision and state your conclusion. Okay, let's do this. I'll take you to the test. Stat. Turn the calculator on. Tests. And watch, guys. T-test. MU0, we're testing against 2,500. X bar, we say it's 2542. The standard deviation is 109. And we took a sample of 24. And what is the sign in the alternative hypothesis? It's a greater than. So watch, guys, I'm choosing the greater than. Enter. You want to do a draw here? Let's do a draw. Let's see if it's going to be shading for the p-value. A little bit. Okay, T is 1.888. And the p-value, just watch, guys, 0.0359. So it's a t-test. Okay, what's alpha here? So we need to see what alpha, 0.01. Can you guys tell me what sign do I put? Is 0.0359 bigger than alpha or smaller than alpha? Oh, this sheet wasn't, no, I didn't include. I'm going to send this sheet in a little bit. I thought it was included, but it wasn't. So I will send this one.
P-value is bigger.
Bigger. Some students are asking me how come they don't have this handout. Okay, bigger. So what's the decision, guys? Fail to reject HO. Okay. If you fail to reject HO, you notice most of the claim happen in fail to reject HO, and my claim is in HA. I cannot support the claim. There is not enough evidence at the 0.01 level of significance to support the credit card company claim. Does that mean that they should discontinue the frequent flyers? Probably. Now, maybe some of you will tell me, well, I see the sample mean to be a little bit more than 2,500, but the question is, guys, is it substantial? If it is not significant, you know, just what's the point of it? Like, for example, someone is taking a medication to up, you know, the good cholesterol. If someone has before like good cholesterol of 35 and then the medication made it up to 36, is that good enough? Probably not, because 1 point, you know, just is not going to make, you know, a heck a lot of difference. And here they have an average of more than $2,500 from a sample of 24, but it seems like this is not significant enough to say that it really works. And that's why we ended up with there is not enough evidence at the 0.01 level of significance to support the claim. All right. Okay, here's another one with the t-test. Fast food outlet. If it's okay, guys, I'm just gonna go over by 10 minutes today, just so I can get done what I plan on doing. A fast food outlet claims that the mean wait time in line is less than 3.5 minutes. A random sample of 15 customers has a mean of 3.6 minutes with a standard deviation of 0.6 minutes. You notice, guys, there is no mention here to population standard deviation. It's all t-test. Actually, the t-test is a lot more important than the z-test, but I did quite a bit of questions on the z-test because it was the section to begin with. That's what section 7.2, and this is 7.3. So the mean wait time is less than 3.5 minutes. So that's the mean, guys, less than 3.5 minutes. That's the claim. That's a good claim. They're telling you if you come to us, you're not gonna wait a lot. You're gonna wait less than 3.5 minutes. Well, let's see how accurate this claim is. So we have a random sample of n equals 15. The mean X bar has 3.6 minutes. Okay, I like it to change this word here. I'm gonna change it later. I'm gonna make it 3.4. I did change it before, but it didn't show here. With a standard deviation of 0.6. So S is 0.6. If alpha equals 0.05, test the fast food outlet claim using the t-test. Assume that the population is normally distributed. Use a TI-84. So it's a t-test, guys, and I'm ready to show you the work. Stat, tests. Okay, t-test. And let's input some values there. mu0, they say it's a 3.5 minutes. I hope that you have a good feel of this already, guys. Then X bar is 3.4. S is 0.6. N is 15. And then we're testing with the alternative sign is less than. Here you go. And if you like, I can do a draw again. Here you go. Oh, huge p-value, guys. So you're gonna fail to reject HO. T is negative 0.646. T-test. 646, and the p-value is 0.2645. It's a huge. So guys, we know that this is bigger than alpha. You're gonna fail to reject HO. And when you fail to reject HO and your claim is in HA, the alternative, you cannot support the claim. There is not enough evidence at The 0.0, what was the level of significance here? Alpha 0.05. Level of significance to support the claim. That means they're lying probably, guys, about their wait time. There is not enough evidence at the 0.05 level of significance to support the food outlets claim. All right. I do suggest, guys, that after you're done with me today, I'm going to send you those blank questions once I'm done. Just get every single question done and try to match it and make sure it matches with what we did here. Okay, next one is number 5. The Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. But Consumer Advocate magazine ran tests of 10 randomly selected cigarettes and found that the amounts are the following. Okay, guys, now he gives us raw data. Before I do anything, let's put the data in L1. Anytime you have a raw data, it's actually turned out to be a t-test. So I'm just gonna do this with you. I'll go to L1, clear my previous L1, and then I'm gonna enter the data. So if you can enter the data, that will be great, and then I'll show you how to do this exercise. So we got 47.3, 39.3, 40.3, 38.3, 46.3, 43.3, 42.3, 49.3, 40.3, 46.3. Okay, so I got my data in L1. It is a serious matter to charge that the company advertising is wrong. If you guys make a claim that an advertising is wrong, you better be able to prove it. Otherwise, you can get in trouble. So the magazine editor chooses a significance level of 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligrams? Because he doesn't believe that the company advertisement, and they believe it is more than 40 milligrams. Assume nicotine levels are normally distributed. So who's making the claim? It's an editor of a magazine, and he's making a claim that they have a nicotine more than 40, although they advertise it's at most 40. So he's saying that their advertisement is false, and I want to prove it. So mean is more than 40 milligrams. That is the claim, guys. And at most, that goes right here. T-test. You ready? We don't need any sample mean or anything. You have the data, guys, so that's all I need. Find the test statistic, find the p-value, etc. Stat, calc, tests, t-test. And look at the difference here. Instead of stats, I go to data because he gave me a summary. Okay, what value are we testing against? We're testing against number 40. Is my list in L1? Yes, it is in L1. Do not change number 3, guys. Leave it at 1. And the editor thinks it's more than 40. Let's see if he's right. If he's right, he can get him in trouble because they're putting a false advertisement. But if he's wrong, they can sue him back. Okay, let's do calculate. T is 2.746 with 3 decimal places. And look at the p-value, 0.0113. I'll write it down. 0.0113. Okay, what's the significance level that we're using here at alpha equals 0? Do you guys agree with me that this is bigger than alpha? It's almost equal to alpha, but it is bigger. So we fail to reject HO. Okay, What do we say? We fail to reject HO because the p-value is more than alpha. We fail to reject HO, so we're saying HO probably good. So probably the company's original claim is okay. Then we cannot support the claim of the editor. So I think he might be in trouble in this case. There is not enough evidence to support at the 0.01 level of significance to support the editor's claim. If he used alpha equal 5%, he would have prevailed, because if he used alpha equal 5%, then p-value will be less than alpha and we reject HO, but he used 0.01. Let me see what do we have here in the chat. Okay. Okay, just 3 more minutes. So guys, I've done section 7.1, 7.2, and 7.3. When we meet next time, it's going to take me probably 15 minutes to wrap up 7.4. 7.5, I'm going to touch on it, but probably I won't test it on the final exam. So we have 7.4, but I'm going to send you some videos for section 7.4. But before you leave, I just want to go back through something that I skipped in the previous handout and explain it quickly to you, and then that should be it. It is right here. Just give me 1 minute, guys, and we'll be done. I promise it will be just 10 minutes. Okay. We did this and that, guys. We haven't done any exercise where the claim is in HO yet. All of the exercises I did today, and I did it on purpose, just so you can have a feel of how you deal with the claims when they are in HA. We did this case. If the claim is in HA and you reject HO, you state that you can support, there is enough evidence to support the claim. So if you reject HO and the claim is in HA, you support the claim. If the claim is in HA and you fail to reject HO, do you guys remember what we concluded here? Can someone tell me, please? What was the conclusion? That there is not what? Enough evidence to support the claim. Now, these two cases we haven't done, but you might encounter some examples in the exercises, so I'm just gonna touch on them. If the claim is in HO and you reject HO, your claim is in the null hypothesis, guys, and you reject the null hypothesis, you state that there is enough evidence to reject the claim. You can have the sheet handy when you do exercises and use, you know, those outcomes to make your decision. And now finally, if the claim is in your null hypothesis and you cannot reject the null hypothesis, you just say, I cannot reject the claim. So say there is not enough evidence at the alpha level of significance to reject the claim. So when the claim is in HO, we use the word reject or not reject. And when the claim is in HA, we use the word support or not support. This is what I want to conclude with today's lesson. So we covered sections 7.1, 7.2, 7.3. We will touch on 7.4 next time, but I'm going to send you some reading materials. Remember, guys, we don't meet the whole time, so you are required to do some reading and some activities outside of the classroom. So I will be sending you some information about the remaining 2 sections. And then We'll visit them on Tuesday, and we start chapter 8 as well.